Oh, we are Good morning, grade 9 learners. Welcome to today's mathematics lesson. My name is Rose Mtimunye, and this lesson is proudly brought to you by the Gauteng Department of Education. So today we are going to build up a little bit more in knowledge on triangles. Remember, we started by learning the definitions of triangles, and then we did similarity, and then we did congruency. So today we are going to do similarity. We are just building up on the knowledge we've learned, okay? But a special request, please make sure you've got a ruler and a pencil in front of you. We are going to measure the triangles during our investigation, okay? Right, so the lesson objectives for today: by the end of the lesson, you should be able to solve geometric problems involving unknown sides and angles in triangles, and you should be able to do this by using the known properties of triangles as well as properties of similar triangles, okay? Your pre-knowledge from grade 7 and 8. You need your properties of triangles, your minimum conditions for similar triangles, as well as your algebraic equations. Alright, so we have a baseline assessment here. I'm going to give you 3 minutes to answer this assessment. We'll come back and then discuss it together. Alright, you have 3 minutes for the session. Welcome back, grade 9s. Remember, we have a WhatsApp line 064-748-8913. You can send us questions. You can also send us pictures of the work that you are doing. Let us assist you if you need assistance with any of the steps you need to take when we answer the questions, all right? So with the baseline assessment, you only had 2 questions, okay? And the first one says, what do you understand by the word similar? All right? So we are going to work through them. So just make sure you've got a pen to correct your work, okay? Right, so my definition, it means the same in shape but not identical, all right? I have an example here of a bear, all right? So I have the mother and the cub, okay? As you can tell, these two are similar animals, all right? And the difference here is that the mother is bigger than the cub. Do you see that? All right, so these two are similar items, okay, or animals. Right, and in the second example we have is that of Matryoshka dolls, the Russian dolls, right? So if you notice with these dolls, they all look the same, right? So they have the same shape. The difference is that they have different sizes. If you can tell, there's a tiny one as you go down there, and then this one is the largest one, right? The trick with these is that they fit inside of each other, right? If you notice, the smaller pieces will fit in the bigger one, okay? So this is what we would call similar objects. Do you understand? All right. Okay, and then the second question was, Well, how do you recognize similar 2D shapes? So now you have an idea of what you'd be looking for when you're looking for similar objects. Okay, you saw your dolls, you saw the cub, you could have also thought of a mother and a baby, right? Now the question is, how do you recognize similar 2D shapes? These are your flat shapes. Okay, how do you recognize them? All right, the first thing is you have to actually be able to measure the sides, so the corresponding sides will be in proportion. Okay, right, what this means is that should you have two triangles and one is bigger and the other one is smaller, for you to get the smaller one to be the same size as the bigger one, you'd have to be able to multiply all the sides by the same factor. Okay, and also you should also be able to do the same with the bigger one to make it smaller. Okay, right, and then you also would check if your corresponding angles are equal. So sometimes the triangles will have two different sizes, but they will have equal angles. So just check those two and then you know that the shapes are similar. Right, so we have a table here. We're going to work through it together. Okay, some parts we are given the description and then we have to discuss or give the term. All right, we've come across some of these terms either today or before. All right, so we are going to work on it. You are welcome to raise your hand in class and give the answer to these questions. Just also make sure you've copied and are filling in the table in your books as well. All right, so for the first one, we have a description. We need to give the term. All right, and it says these are triangles that are the same shape but have different sizes. Okay, so what do we call triangles that have the same shape but different sizes? You can raise your hand in class. All right, somebody has an answer already? Okay, well done. So what do we call them? We call them similar triangles. All right. Okay, now you know what similar triangles are, then you definitely should be able to define similarity, right? So we need a description for similarity. You can raise your hand in class. All right, somebody has an answer? I trust you were able to give it because we've just done this in our baseline assessment. All right, similarity means that they have the same shape but they have different sizes. All right, okay, this particular description we've seen in our geometry of lines as well. It says angles at the same position on each intersection. What type of angles are those? These are your corresponding angles. All right, so if you have all of those, well done, you still know your terms. That's very good. Okay, right, so as we know, we are discussing similar triangles. We are going to start off by doing a small investigation together. All right, so what I'm going to do, I'm going to just first introduce the symbol for similarity. Do you see what the symbol looks like? It's like three eyes. Okay, three lines standing upright, or they can sometimes be a little bit skewed like those ones. All right, just to remind yourself of similarity, you can think of the dollar sign. All right, and maybe you can just introduce one more line. I introduced the line there so that you can have the symbol for similarity as well as the S from the dollar sign will remind you of similarity. Okay, if you've forgotten that, you can just look at the word similarity. Do you see that it has these eyes? There's three of them, just like in the symbol. All right, so you can use one of those to remind yourself what similarity looks like mathematically if you're asked a question about similar triangles. All right, right, so if two triangles are similar, then their corresponding angles are equal and also their corresponding sides are in proportion. All right, right, there are two ways to prove that triangles are similar. The first one, you have to prove that the angles are equal. Okay, so what you do is to prove that the angles are both equal. The angles on the left triangle are equal to the triangle on the right. Does that make sense? Okay, and your reason would be angle, angle, angle. So at least three angles, right? And then the next one, you'd have to prove that the corresponding sides are in proportion. All right, so Okay, so the corresponding sides in the first triangle would have to have the same proportion as the angles as the sides in the second triangle. Okay, right. You only need to prove one of these when you are working with triangles. All right. Okay, so I'm going to give you 1 minute, just a quick 1 minute, just to sketch these triangles. They don't have to be up to scale. Just sketch 2 triangles that look like this in your books. So I'll give you 1 minute, and then we'll go to start and do our investigation after this. All right, okay, so you have 2 triangles. You've labeled them triangle ABC, and you also have a triangle DEF, right? Okay, so now we are going to start measuring the sides. We are first going to measure the sides for triangle ABC. As we measure the sides, will you please record the measurements on your triangles? All right, so we are going to measure them here on screen, and then you are going to record these measurements in your books. All right, so for the side AB, what is the length? Okay, do you have a length? How's that? All right, for the next side, so you did get 9 centimeters for the first side, right? Okay, now for the second one, I think you can see this one, but I'll just zoom in a tiny bit for you. Right, everybody has this one? Okay, okay, so you're going to record that. Please do write the value that you got. All right, so that was 12 centimeters for the side BC. Okay, and then the last side, be careful with this one. Okay, be very, very careful. Do you see that my ruler goes past the centimeter units? Okay, it has a little bit extra millimeters, so just be careful. Okay, you have it. All right, so that one is 15 centimeters. Okay, so triangle ABC has those sides. So now we are going to measure the second triangle, triangle DEF. We are starting with EF. I think you can see, but I'll zoom in just a little bit for you. You're able to record that? Okay. Right, that's 8 centimeters. And now we're going to measure this side, DF. You can see DF, right? Okay. And that's 10 centimeters for the final side. Can you see it? Let's zoom in a little bit. There you go. You have it. All right. Okay, that becomes 6 centimeters for that side. Right, now you have your 2 triangles, and they both have values on the sides, right? Remember, I had asked you to sketch 2 triangles that look like the ones we have here on screen. Okay, now from here, remember we had an example of our Russian doors where one of the doors, the smaller door, can fit into the larger door. Even with similarity, we can use the same analogy and think that similar triangles, because they have the same shape, they should actually be able to fit on top of each other. The only difference is one of them will be bigger than the other one, right? So we can rotate this shape, okay? And now we definitely are sure that these two have the same shape, okay? And when we place it on top of the second triangle, it fits perfectly inside of the triangle. So we definitely have an idea that these two are similar triangles, okay? Right. So now let's use the sides we've just measured, all right? Let's use the sides we've measured to do our investigation. So we are going to do side ratios, all right? I'll do the first side with you. So the two longest side. What's important with your ratio, remember ratio is actually a value divided by a value, right? You know that it's like your integer over an integer. It can be a fraction, but what you're looking for is where you're dividing two values, okay? So we are going to do the two longest sides, two middle sides, as well as the two shortest sides, all right? So with that, we are going to start with DF. I'll do that as the example, which means for me in these triangles, my values for the smaller triangle, because I have DF over AC, my values for the smaller triangles will be at the top. They'll be my numerator, okay? And then the values for the bigger triangle will be my denominator. Remember, this is not a rule, okay? You can start with the values for the bigger triangle and then as your numerator, and then use your values for the smaller triangle as your denominator, okay? Just be sure that you will get either 3 over 2 or 2 over 3 for those ones, and whatever you do, they must be the same ratio, okay? So just be careful with that, all right? Okay, so for the first one, I had DF divided by AC. So DF is 10 centimeters and AC in the bigger triangle is 15 centimeters, right? Now I have 10 over 15. What did I do? I then found a common factor between 10 and 15, which was 5. So I divided 10 by 5. That gives me the 2 I have here. And then 15 divided by 5 gives me the 3 I have there. All right, I'm going to give you 1 minute to answer for the sides, for the two middle sides and the two shortest sides. So please write your ratios for those two. You have 1 minute to do that. All right, remember grade 9, 064 748 8913 is our WhatsApp line. So do send us questions, and you can also send us pictures of the work that you are doing in your books. All right. Okay, so I had asked you to find the two middle sides, their ratio. So starting with the smaller triangle, okay? The middle side for the small triangle is EF, do you see? Okay? And a value here in the bigger triangle that is between would be the 9 centimeters. Did you notice that? Okay, so we are working with EF and 9 centimeters is a small one, so we are working with BC here. Okay, this is the middle value. All right, so we have 8 divided by 12. Okay, then we find a common factor between the two, and that would be a 4. So 4 into 8 goes how many times? It goes twice. And into 12 it goes how many times? 3 times. That's our ratio there. We have 2 over 3. Right, so if you have that, well done. Okay, for the next one, we have DE divided by AB. So the shortest side of our triangle there divided by this short side that I almost used as a middle side. Okay, so we have 6 divided by 9, right? Okay, then we find a common factor, which is 3. So 3 into 6 goes how many times? It goes twice, and into 9 how many times? 3 times. And that's where we get our ratio there. All right. Okay. Now we have ratios. What is your observation about these ratios? Okay. What you should have noticed was that this means that the corresponding sides of the triangles are in proportion because they all have the same ratio. All right. Okay. Therefore, triangle ABC is similar to triangle DEF. You see we've used our similarity sign there. Okay. Right. And your reason would be sides in proportion. Okay, we have our first activity. Okay, this activity is just about you being able to use the notation. Okay, just for you to be able to use the notation when you're given that two triangles are similar. So I'd just like to see how you're able to identify the equal sides and the equal angles. Okay, so you're not proving similarity, you're just identifying the equal angles and the equal sides. You will have 2 minutes to do this question, and then we'll come back and do it together. All right, welcome back, grade 9 learners. Please do send us pictures of this work as you are going through it. We would like to see how you are doing. All right, so the activity says state which sides and angles are equal if you are given that triangle ABC is similar to triangle DEF. Right. What's important is for you to notice and note that the vertices in which these triangles are listed are very important because they are the ones that tell you the corresponding angles and the corresponding sides. Okay. Right, so we are going to work with triangle ABC and triangle DEF, right? So in triangle ABC, angle A is equal to angle D. Do you see that? We can either look at our diagrams here. They both have the same symbol, so we know they're equal. But also we can actually look at the given notation here. Triangle A corresponds with triangle. Angle A corresponds with angle D. Do you see that? Okay. And then what's the next pair of angles that are equal? See, angle B corresponds with angle E. Therefore, those two are equal, right? And the last pair is this one. Angle C corresponds with angle F. So those two are equal. Okay. So if you have all three of those, you would get a mark for each of the angles that you were able to identify as equal. Now you also have to find the sides. So when you're working with the sides, you're working with ratios, right? So you just need the two letters in each triangle, and you use the other two letters in the second triangle so they correspond. Okay, so we are going to divide the big triangle by the smaller triangle. So AB, it's this two, will correspond with DE. So we are going to say AB divided by DE. Okay, it will be equal to, because we are told they were similar, so their ratios must be equal. It will be equal to what? Which side? BC and EF. All right. So it will be BC divided by EF there. Right, you get that. Right. And then the last pair of sides we are using would be this A side and that one, the first letter and the last letter. So AC divided by DF would be the last pair. Okay. So if you have these three sides, these three ratios, then you also get a mark. All right. Okay. For this, just remember to pay attention to, I want to clean this up. Okay. Just remember to pay attention to your notation, all right? This is very important. Even if you are asked to just prove that the triangles are similar, make sure after you've done your statement and your reason, you go back and check which angles did I say are equal. Then if you said angle A is equal to angle D, that means you need to rename your triangles to start with A and D, okay? So that you know you are matching the corresponding angles, okay? Very, very important. All right, okay. Now we're going to try an example. It says study the figure and answer the questions that follow. The first question says prove that triangle ABC is similar to triangle PQC, and you also have to use your statement and your reason. The second one says calculate the length of AB if AC is equal to 10 units and PC is 4 units and PQ is 2 units, all right? And you also here are required to use your statement and your reason. Okay. Okay, so for the first one, you're asked to prove that triangle ABC is similar to triangle PQC. So this one, I'm going to give you some clues and then you're going to fill in some of the information. So on one side, we have statement and on the other, we have a reason. Remember to tell the examiner which two triangles you're working with. In this case, we have two triangles and one of the triangles is actually nested inside the second triangle. So it's very important to state which triangle you're focusing on or with, because you might end up with a diagram where you have 3 or 4 triangles in one big shape. Okay, right, so I'll do the first one with you and then I'll ask you to continue with the rest. Okay, so here you're given a reason and it says you have something in common. These two triangles have a common something and you're asked to give what that is. All right, so we go to our diagram and we look. We have two triangles here. The big triangle is ABC and the small triangle is PQC. Right, what do they share? They share the angle at C. Did you notice that the angle at C is actually common because you use that angle for triangle ABC and you also use that same angle for triangle PQC. All right, so you can also confirm on the notation given that yes, actually angle C and angle C are corresponding angles. Therefore, they have a relationship and in this case, it's a common angle. So on your statement there, you're going to write angle C is equal to angle C and you've been given the reason as common. All right. Now I'm going to ask you to continue from here. I'll give you 2 minutes to fill in the rest of these steps. Okay, so welcome back, grade 9. If you have questions, 064 748 8913 is the WhatsApp line for you to use. All right. So you had a diagram that you were supposed to extract information from, and you fill in your statement and reason to prove that two triangles are similar. Okay, now you had to find another relationship between angle B and angle Q2. So angle B is in the bigger triangle and angle Q2 is in the smaller triangle. What relationship do they have? Alright, for you to recognize what relationship they have, you should have noticed that these two lines are parallel. They have these symbols for parallel lines. So those two lines are parallel. And as soon as you see parallel lines, you also look for your transversal. And in this case, we actually have two transversals. One on the right hand side, which is BC, and on the left hand side, AC is also a transversal. Did you notice that? Okay. So what this means is we can work with fun. Okay. So we can look for either an F, a U, or N shape. Okay. Now, which two types have equal angles? It's either corresponding angles or alternating angles. And in this case, let's identify angle B and also identify angle Q2. Are we able to see a relationship yet? All right, what if we drew an F? Do you see the relationship now? Right. What type of relationship gives you an F shape? Those would be your corresponding angles, right? Just to be sure, we go and check on our notation. Does B and Q actually have a relationship? Yes, B and Q do have a relationship. So this statement will definitely be correct. Corresponding angles, and you state your lines that AB is parallel to PQ. Okay. For the next one, we are told that there's another pair of corresponding angles, and we have to identify that pair. All right. So angle A and angle P there, because they're also between two parallel lines and a transversal. Do you see? Okay, those two angles are corresponding angles. Did you notice? You can just check, does angle A have a relationship with angle P on your notation? Yes, there you go. Angle A corresponds to angle P, and in our case it corresponds to angle P2. Okay, so angle A is equal to angle P2. Right. Now the final step, when you're asked to prove that something is similar to something else, in your final step, that's what you need to state. You need to state what you have proven, right? Therefore, triangle ABC is similar to triangle PQC. And what would be your reason? Your reason is that you've proven three angles equal, so angle, angle, angle. Okay. Right. This one says calculate the length of AB, all right? And if AC is 10 units and PC is 4 units and PQ is 2 units, all right? So what I'm going to do, I'm going to give you 2 minutes to answer this question, and then we are going to work on it together. Okay, welcome back, grade 9 learners. So with this question, you are asked to calculate the length of AB. So you know already that you are only looking at the information provided about the sides. But when you look at your diagram, there is no information on the diagram. Yet you've got some information provided in the instructions. So what do? You have to first take that information and place it on your diagram so you know what it means with the relationship on your diagram. Okay, so first you have AC is equal to 10 units. So you go to your diagram and you label that, right? And then you have PC is equal to 4 units. So you label PC as 4 units. And also PQ is 2 units. You label that as well. All right. Now you've labeled all the sides that you have information about. This will come in handy. And you need to remember that you've just proven that these two triangles, triangle ABC and triangle PQC, are similar. That will also come in handy when you are looking for the side AB. Okay, so because we know that we've proven that these two are similar, we can actually use their ratios, all right? So AB divided by PQ is equal to BC divided by QC and AC divided by PC, all right? And your reason would be that these two triangles are similar, and you've proven that as well. Right, now you check what information can you use, right? So now you're given the side AC as 10 units, so you can tick that off as one of the sides you have information about. What other information do you have? You also have the side PC. Do you see? The side PC is 4 units. So you have that information. You can tick it off. And what else do you have? You have the side PQ as 2 units. All right. Okay. And obviously you're looking for AB. So those two are the ones you are working with. Okay. Because you're working with AB. So you need these two fractions. From here, what do? You now have to substitute the values of these angles, okay, of these sides. So AB divided by 2 for PQ is equal to 10 divided by 4, all right? So what you've done here, you've just taken all the values and you've plugged them into place where they need to be. You've substituted all those values, okay? From here, what you can do is to either cross multiply. By cross multiplying, you take the denominator from the left hand side and multiply with the numerator on the right hand side of your equation. And you can also do that with the numerator on the left multiplied by the denominator on the right of your equation. Okay, so when we do that cross multiplication, we end up with AB times 4 and 2 times 10, which gives us 20. All right, and from here we still have to isolate our AB, so we divide both sides by 4, and 20 divided by 4 will give us 5 units. Okay, you could have also, from this step, you could have also worked with your multiplication. So you have AB divided by 2 is equal to 10 divided by 4, right? Now what you could have done was to multiply both sides by 2. You multiply this side by 2, okay? What this would have done would have cancelled those 2, and then you would have left with AB on the left. And here, this is 2 over 1, right? So 10 times 2 gives you 20. So I'll squeeze my 20 there. And 4 times 1 gives you 4. And you still get AB is equal to 20 divided by 4, which is still 5 units. Okay, so you can use one of those two methods. I hope you understand that, right? Okay, so we still get 5 units for those. For this example, it says study the figure below and answer the questions that follow. Calculate the length of PS if triangle ABC is similar to triangle PTS. So in this case, they've already proven to you that they've already decided that the triangles are similar. All you have to do is to use the information provided to find the side, which is labeled X there. PS is given as X. Okay. All right, for this example, I'm going to give you some time to work through it, and then we're going to come back and work on it together. So first, to find PS, I will give you 2 minutes, then we'll come back and do it together. Okay, so grade 9s, now that you know what to look for when you're given similar triangles, I trust this was a little bit easier for you because you are able to find the relationship of the sides just by looking at the notation given about the similar triangles. Were you able to do this? I really hope you were. But if you have any challenges, please send us a WhatsApp on 0647488913. We'll assist you in answering these questions and also in finding the next step or the first step that you should have taken to do these questions. All right. Okay. So you are asked to study the figure and answer the questions. And it says calculate the length of PS if triangle ABC is similar to triangle PTS. All right. So the first thing was for you to find the relationships between the first triangle and the second one. Okay. In this case, I started with the triangle PTS as my numerator, and then the triangle ABC is my denominator. Why am I doing this? I'm doing this so that the unknown side that I'm looking for will end up on the left as a numerator. Okay. It becomes easier, especially if you want to use that method where you multiply by the denominator both sides. All right. So do that. Always try to do that so that your unknown is at the top on the left. Okay. Try that. Use your unknown as a numerator wherever possible. Okay. So we have PT divided by AB is equal to TS divided by BC, which is equal to PS divided by AC. From here, you check, okay, first let's give our reason. So first, we've just checked the sides. AB corresponds to PT, therefore, we are correct in that case. And also, what else can we check? We can also check that BC corresponds with TS. So, yes, that's also fine. And the last one would be the first and the last letter. So, AC corresponds with PS. You can use this to help you when you're not sure what sides or what ratios to use to do your similar triangles. Okay, right, and your reason would be given because you were given that these two triangles are similar. Okay, and from here you just check what information do you have on your diagrams that you can use. So you just check everything that's given. So PS is given. Okay, yes, it's given not as a value but as a variable, but remember that's what we're looking for, that's why we're taking it off. And then AC is also given. We also have information about TS, and we also have information about PT, and we are asked to find PS. So we use the fraction with the most information as well as the fraction with the side that we are looking for. Okay, so now I have substituted my values. I have x divided by 12 is equal to 2 divided by 6. So what I've done here, I've just substituted all the values for the sides onto my fraction. Okay, and then in this method, I'm going to first do the cross multiplication method. So x times the x is your numerator, right? So you're going to multiply with the denominator on the right, and you are going to have 6x, and then 2 times 12 gives you 24. All right. And from here, you divide both sides by 6. 6 divided by 6 here will give you 1. And 24 divided by 6 will give you, do you know how to do your math? It will give you 4. Right. Now you have x is equal to 4, but you're asked to find PS. Just to avoid any confusion, you therefore state, therefore PS is equal to 4 centimeters. Okay. You could have also used your multiplication, okay, where you would have had to multiply both sides by 12. You can also do that. Okay. Please don't write this under your reason. I just have space on reason, okay? So don't confuse it as the reason, okay? All right, so we have x divided by 12 is equal to 2 divided by 6, right? Then we multiply both sides by 12 over 1. Multiplied both sides by 12 over 1. Okay, you're still with me? Right, so on this side, 12 will go into 12 1. So we have x is equal to. This side, we multiply the tops with the tops and the bottoms with the bottoms. So we have 12 times 2, which gives us 24, divided by 6 times 1 gives us 6. So you have 24 divided by 6. Do you see it's the same fraction as this one? All right. And then from here, you can say 6 into 24 goes how many times? It goes 4 times. So you still have 4 centimeters. All right. So whichever method you are able to use, you can try it out. Okay, we have homework here. For this homework, I'll give you 5 minutes to copy it down, and then we'll come back and check if you have any WhatsApp questions, as well as go into our summary. All right, welcome back, grade 9. So please remember to make sure you read the question, okay? Once you've read the question, you check that all the information provided on the question is actually on your diagram. That's very important because you assume that the information on the diagram is all the information you have. So if you've noticed SR is equal to 6 centimeters, that is not on your diagram. So you must go back and include that on your diagram, all right? And I hope you've also noticed that PQ is parallel to TS. So you saw parallel lines. What relationship should you also be looking for? You will be looking for fun, okay? So just make sure you check that information when you do this homework, all right? Okay, so I'm going to check if you have any WhatsApp questions or if you've sent us any messages. And then after this, we are coming back to our summary. All right, let's see who has been in touch with us. Okay, so today we have work from Winila Secondary School, and it says state which sides and angles are equal if given that triangle ABC is similar to triangle DEF. All right, okay, well done. You have all the angles correct. Okay, just a tip when you're doing this, because you can't have two equal signs, just use the 3 dots, therefore. Okay, you just use the 3 dots to indicate therefore. That way you won't have 2 equal sides on the left and on the right. But very well done. I like that your work is so neat. Okay, that's a very, very good thing. Okay, right, so now we don't have any other questions, so we are going to go back to our summary, and then from there we are going to see what is next in our lesson. Okay, all right, so for the summary, we said that we only need to prove 2 points about a triangle for them to be similar, and the first point was that their corresponding angles are equal. Okay, what does this mean? It means that if you have this triangle here, I hope you can see it, and my artistic skills are gone now. Okay, if you have this big triangle, which we can call A, B, and C, and you have, let's make this one slightly bigger, this one here, we can call it PQR. Okay, these 2 triangles. All right, for you to prove that the corresponding angles of the triangle are equal, so if you're saying this angle at A is equal to that angle at P, and you also prove that the angle at B is equal to the angle at Q, and the angle at C is equal to the angle at R, we need 3 lines. Okay, once you've proven that these are equal, what you've basically done was to prove similar triangles. Remember, similar triangles just means that they have the same shape but not necessarily the same size. Okay, right, and then to prove that the corresponding sides of the triangles are in proportion, what you'd have to work with here is to look at which sides are given as either equal, right, and then you'd maybe divide those 2 sides. All right, so here these 2 would be corresponding, and then AC would correspond to PR. Okay, that's basically what you'd have to do to prove that the corresponding sides are in proportion. And you remember that for this to happen, you'd have to use your ratios. So AB divided by PQ, they have the same symbol, divided by PQ would be equal to, what's the next ratio? BC. Okay, BC, do you notice I always start from the first triangle I used, divided by QR. Okay, and what would be the last one? AC. So we have AC divided by PR. All right, that would be the last one. You remember this, right? Okay, we've done this. Okay, right, so please remember to click the complete button at the bottom of your screen. We don't have a lesson for next week because you are currently going on school holiday. So I will see you definitely in the next term, which is term 4. All right, So thank you so much for joining us today. This lesson was proudly brought to you by the Gauteng Department of Education. Remember to sanitize, wear your mask, and keep social distancing to protect yourself and those you love. All right. Thank you.